Hello everyone, myself Dhruv Kumar, working in Mechanical Engineering Department, IIMT College of Engineering, Greater Noida. So today video lecture I will explain types of governor. So these are the content which I will deliver. Governor, classification of the governor, centrifugal governor and its terminology, and next categorization is types of governor, Watt governor, Porter governor, royal governor, Hartnell governor, and some different terms: sensitivity, stability, isochronous, and hunting of the governor. So, what is governor? So, basically, governor, it is also known as a controlling or speed limiter, is a mechanical device that is used to automatically maintain and regulate the rotary speed of the engine or other prime mover, and which is used to basically regulate the supply of the fuel according to the wiring load condition. So basically, primary function of the governor is to regulate the engine speed with wiring load condition. So basically, it allows the engine to run at speed you select without any effect of the changing of the load. So if there is no any change of the load, so engine is running at the constant speed, and there is no requirement of the governor, or you can say that the supply of the working fluid is constant, and governor is running at the constant speed. So main purpose of the governor is to control the flow of fuel into the engine to maintain a constant speed, and sometimes it is also known as the speed limiter. So there are basically two conditions. One condition when load on the engine is increases, and another condition is when load on the engine is decreases. So first condition, when the load on the engine increases, the speed of the governor decreases, and vice versa of this, when load on the engine decreases, the speed is increases. So basically, I have already discussed the governor plays very important role to increase or reduce the fuel flow to engine according to the requirement inside the engine cylinder. So there are in this slide basically discuss the supply of the fuel according to the loading condition. So first condition, when the load on the engine increases, automatically you can say that whenever we will increase the load on the engine, its speed is decreases. So therefore it becomes necessary to supply of the working fluid inside the engine cylinder to maintain the mean speed of the engine. And in second way, when the load on the engine decreases, its speed is increases, and less working fluid is required to maintain the mean speed of the engine. So governor basically automatically control the supply of working fluid to engine with wiring load condition, and keep the mean speed of the engine within the certain limit. So if we will talk about the application point of view of the governor, it is generally used in generator and turbines. So there is another important term. What is the difference between the flywheel and governor? So function of the basically flywheel is to in the engine is to be basically uh, regulate the variation caused by the due to the cyclic variation. So you know that in four-stroke engine there are one stroke that is called the expansion stroke. In this stroke, you will get the energy, and for the remaining stroke, you will not get the energy. So the excess energy is stored in the flywheel in the term of the kinetic energy, and for remaining stroke, which is not given the energy, so these excess energy is stored in the remaining stroke. So flywheel comes very important role whenever there is a cyclic variation inside the engine. So in single stroke engine there are very big or large flywheel is required, and whenever you will increase the number of cylinder, the flywheel size is also reduced. So the function of the flywheel in the engine is entirely different from that of the governor. It controls the engine speed variation caused by the fluctuation of the engine turning moment during each cycle of the operation. Basically, it does not control the speed variation caused by the wiring load, and the wiring demand of the power is made by the governor, regulating the regulating the working fluid. So next, classification of the governor. Governor is classified basically in the two types: centrifugal governor and inertia governor. Centrifugal governor is further classified uh, dead weight governor, spring control governor. Dead gate governor is further classified Porter and Troil, and spring control governor is classified as Hartnell governor, Hartnell, Wilson Hartnell, and Pickering governor. So next is the what is the principle of the centrifugal governor. So basically, as the name suggests, the centrifugal governor is work on the principle of the centrifugal force. So if you will talk about the different terminology of the governor, basically it have four arms, and these four arms basically running with the spindle. So these are the spindle, and this is the upper arm which is connected to the upper pivot on the spindle, and this is the lower arm. Yeah, you can say that it is the link, and these lower arm basically connected to the sleeve. So upper arm basically connected to the fly ball, or simple you can say that ball of the governor, and the sleeve is directly connected to the bell crank lever, and bell crank lever is connected to the supply of the fuel. So the spindle is running through the bevel gear, and the basically this spindle is running by the uh, engine shaft, and engine shaft is connected to the bevel gear. So what will happen here when there is a fluctuation in load? So the speed of the spindle is also increasing or decreasing. According to increase or decrease of the spindle speed, the centrifugal force on the flywheel is also increases or decreases. So due to the increase or decrease of the centrifugal force on the flywheel, the movement of the sleeve is also take place. So basically the centrifugal governor are based on the balancing of the centrifugal force on the rotating ball by an equivalent opposite radial force, and that radial force is known as controlling force. So basically the value of the controlling force is equivalent opposite to the centrifugal force when governor is in equilibrium position. So amount of the centrifugal force is equal to the controlling force, and that will be the m omega square r, where m is the mass of the flywheel, r is the radius of the governor, and n is the speed of the governor. So basically, centrifugal governor, I have already discussed. The centrifugal governor consists of two balls of equal mass which are attached to the arm. These balls are known as the governor balls or fly balls. And these balls are basically revolved with the spindle, which is driven by the engine through the gears. And upper end of the arm are pivoted to the spindle so that ball rise up or fall down in the vertical axis. Next, the arm are connected by the link to the sleeve, means lower arm is connected to the sleeve, which is basically key to the spindle, and this revolve with the spindle and also move up and down. The ball and the sleeve rise when engine speed is increases, and ball and sleeve moves downward direction when engine speed is decreases. And this basically sleeve is connected to the throttle valve through the bell crank lever. Next, working of the centrifugal governor. There are two conditions when the load on the engine is increases, and another condition is when the load on the engine is decreases. So first condition, when the load on the engine increases, thus when the load on the engine increases, thus basically speed when the load on the engine is increases, the engine and the governor speed decreases, and if you will want to maintain the mean equilibrium of the speed, so you will need to increase of the fuel supply inside the engine. So by the increasing the fuel supply, you can maintain the mean speed of the engine. Next, when the load on the engine decreases, the engine and the governor speed increases, and results in the increase of centrifugal force on the fly ball. Thus, balls moves outward direction and sleeve rise upward, and this upward movement of the sleeve basically reduce the supply of the working fluid. So that by the reducing the supply of the working fluid, we can maintain the mean speed of the engine. Next, different terminology of the governor. First is height of the governor. So as basically shown in figure, these are the red vertical lines show that is spindle axis, and these are the basically upper arms. So basically height of the governor represent the vertical height from the center of the fly ball to the both upper arm intersect at the governor axis. So at indicated in this diagram, h is the height of the governor. Sometimes these upper are not intersecting on the spindle axis, so you can extend the both upper arm, and whenever these upper arm may lie on the spindle axis, so height of the governor is measured on the this way. Next, sleeve lift. Sleeve lift is the basically vertical distance of the sleeve travel due to change of equilibrium speed. Next, equilibrium speed. Basically, we can say that the governor is in equilibrium when governor ball's arms are does not moves upward or downward. So, in this situation, you can say that the governor is in equilibrium speed. Mean equilibrium speed, the speed at which uh, the balls is in the mean position. Next, maximum and minimum equilibrium speed. Maximum equilibrium speed, the speed at which the governor is in the extreme position. So if your governor is in outward extreme positions, in this situation, you can say that the governor is in maximum equilibrium speed, and whenever the ball in minimum extreme position, in that case, governor have the minimum equilibrium speed. So here basic primary motto of the governor is to calculate the basically range of speed, or you can drive the relation of the speed of the governor. So if we talk about the categorization of the governor, first governor is watt governor. So I have already discussed the terminology of the governor here. M is the mass of the ball in kg, Small w is the weight of the ball in Newton, that will be equal to the m into g. T is the tension in the upper arm in Newton, and omega is the angular velocity of the arms. R is the basically radius of the governor, and Fc represents the centrifugal force which always act on the outward direction, and H is the height of the governor. For in this governor, there is a assumption that he neglect the tension on the upper and lower arm, and also neglect the weight of the arms. So, or in this case, you can take the moment about the O. So, after taking the moment, this equation is generated. Fc multiplied by H equal to W multiplied by R, and W is equal to mg into R, and Fc equal to m omega square R into H. So here m both cancelled. So H is equal to g divided by omega square, and here you can put the value of the omega, that will be equal to 2 pi n divided by 60. So final equation will be generated. H is equal to 895 divided by n square. This equation basically suggests that H is inversely proportional to 1 by n square. Uh, or we can say that whenever the speed of the governor is increases, the height of the governor is also reduces. So for very high speed, the height of the governor is very small. So the height of the governor is h is inversely proportional to n square. Therefore, at high speed, the value of h is small. At such speed, the change of value of h corresponding to the small change in speed. So basically, final conclusion is this governor is basically work on the low speed for 60 to 80 RPM. For high speed, basically this governor is not work satisfactorily. Yeah, you can say that the mechanism is not able to enable at the high speed. So in Porter governor, if you will talk about the basic construction of the Porter governor, the flywheel is connected between the intersection point of the upper and lower arm, and a central load is placed on the sleeve. So, after placing the central load on the sleeve, the tension on the upper and lower arm is increases. So, in this case, tension in the upper arm and lower arm cannot be neglected, and the load on the sleeve is also increases because here we have placed a central load W. So, another diagram is basically the different force acting on the free body diagram. So in this case, basically we are taking half portion of the governor. So the half load is W by 2 acting on the D point. Total load on the central sleeve is W, and the half load is W by 2. And tension on the upper arm is T1, and tension on the upper arm is T2. And basically beta is the angle of lower arm to the vertical, and alpha is the angle of the upper arm to the vertical. So here if you talk about the equilibrium speed, we can calculate the equilibrium speed in two different way. One is the equilibrium method, and another is the instantaneous center method. So in equilibrium speed, if we will consider the equilibrium of point D and equilibrium of point D, and resolve the horizontal and vertically. So if we talk about the final equation generated by this governor is n square equal to m plus capital M divided by 2, 1 plus q divided by m, and multiplied by the 895 divided by h. And if we will talk about the friction generated on the uh, sleeve sleeve. So if you consider the frictional force, the equation is modified to n square equal to mg plus capital Mg plus minus f, where f is the frictional force between the sleeve and the spindle, divided by 2 1 plus q divided by mg multiplied by 895 divided by h. Next, Royal Governor. There are basically minor difference between the Porter and Royal Governor. Basically, in this Governor, lower arm is extended parallel to the Governor axis, and a ball placed in this position. In Porter Governor, basically ball placed in intersection between the lower and upper arm, but in Royal Governor, ball is placed from few distance from the intersection point of the lower and upper arm. So there is minor modification in the equilibrium speed also. So equation for the equilibrium speed in this governor is n square is equal to fm divided by bm, where fm is the basically distance from intersection point to the horizontal line, and bm is the distance between the center of the fly ball to the horizontal line. So fm divided by bm, m plus capital M by divided by 2 1 plus q divided by multiplied by 895 divided by h. Next, Hartnell governor. So basically in Hartnell governor we are placing the spring on the spindle. So due to the position of the spring in spindle, the sleeve movement, the fluctuation of the sleeve is also gradually. In portal governor basically is a very sensitive governor. So whenever you will increase or reduce the load on the engine, there are sudden change in equilibrium speed, and sleeve movement is more. So by placing the spring on the spindle, the sleeve movement is basically regulated. So we'll talk about the basic construction of this governor. In the spindle, we have placed the sleeve. Fly ball is placed in vertical arms, and basically this is the frame portion. And nut is also placed here. By the use of the nut, you can adjust the spring force by losing or tightening the nut. So basically, if we talk about the pre-body diagram, we have basically two position. One is the minimum position, and another is the maximum position. For minimum position, basically fly ball moves inward, and for the maximum position, fly ball moves outward to the mean position. So in minimum position, whenever the fly ball moves inward position, the sleeve moves basically downward position, and according to that we can calculate the basically total height of the governor and engine speed. Next is the different term used in the governor. First is the sensitivity of the governor. So basically governor is said to be sensitive if it readily respond to the any change in the speed. So basically sensitivity defined when there is a fraction change of the speed, the movement of the sleeve is generally referred as the sensitivity of the governor. So sensitivity basically also calculated with the help of this relation n2 minus n1 divided by n, where n2 minus n1 is the range of speed and n is the equilibrium speed. Next, stability of the governor. A governor is said to be stable when the average speed within the range, or you can say that the whenever the you can say that governor is stable when there is only one radius of rotation. Next, isochronous governor. When the equilibrium speed of the governor or already of rotation of the balls within the working range. So you can say that it is the condition of the isochronous governor, or in the simple way, the range of speed equal to 0 means n2 minus n1 equal to 0. So you can say that it is the isochronous governor. Next, hunting of the governor. Basically, hunting of the governor is occurred when governor has too much sensitive. So governor is said to be hunt if the speed of the engine continuously fluctuate above and below the mean speed, and this is basically caused by too sensitive of the governor. If governor is too sensitive, then change of fuel supply is also sudden. So, for example, when the load on the engine increases, the engine speed basically decreases, and if the governor is very sensitive, the governor's sleeve immediately basically falls, and if the due to the falls of the governor in the governor sleeve in the lowest position, the opening of the throttle valve and a sudden supply of the fuel inside the engine cylinder. So, due to the sudden supply of the fuel in the engine cylinder, the speed is the burning of the fuel is more, and speed is automatically increases, and governor is more sensitive. So basically, sleeve hit the upper position of the spindle. So basically, this process is repeated again and again due to the sensitivity of the governor, and governor basically sleeve is hunt upper and lower position, and fuel supply is also frequently changes. So thank you.